Hello everyone, welcome to my channel. If you have watched this video for the first time, this is the channel where I intended to teaching the engineering mechanics from the scratch. You are in the concept of projectile motion. We are at the problem number 7. Okay, so enough with the introduction. In problem 7, if you have seen the previous video, problem 6, we have dealt with the projectile motion in the inclined surface as to determine the distance, inclined distance where it landed. But this time, slightly different. I adjusted question so that to intrigue you are interested in projectile motion according to a various surface that combine. In this case, I use circular surface combined with the flat surface. Okay, so firstly, let's look on how the question state and what they are giving us, what they ask us to find. Okay, so don't worry, you look it one by one together. Okay, this is interesting. One of the interesting problem I have made tutorial. So make sure you uh, pay full attention on this question. Okay, let's go. So the projectile launched from point A to B with initial velocity of 70 meter per second with 35-degree angle above horizontal line. So they asked us to find if the projectile landed on the circular surface, what will be the x and y coordinate of the contact point. Okay, so the reference of the x and y already here stated from the start of the projectile. Y is upward, x is on toward the right side. So they asked us what is the x and y coordinate in this circular path. Okay, so they're giving us the horizontal distance from A to B, which B is the start of the curve of 200 meter. So before, uh, and then after that, they're giving us the vertical distance, okay, from B to C, which is 150 meter. We clearly see that should be the radius that they are giving us. Okay, find the final coordinates and the flight time that projectile will impact on the curved surface. Okay, interesting. So let's look at one by one. Okay, so firstly, as always, I pull off this equation for solving the distance in y-axis, which is this yellow box equation. You should have been seeing this multiple times if you are watching the video I made. But again, to briefly introduce this equation used for the the vertical displacement determination that will be including the acceleration in y-axis, which in this case is the gravity itself. Okay, so Sy, clearly the distance of Sy is starting from the horizontal of A toward the final point, the impact point here. And Sy of us should be our final y coordinate. Okay, that uh, that is one obvious notice from this curve position. So since we don't know Sy, we will plug in Sy as variable here. Okay, equal to Vy, which is the velocity in y-axis of 70 meter per second times sine 35. That is the distribution of the velocity, as we always know. And then the gravity, put minus sign in front of it because the positive y direction is upward. Okay, so the gravity going downwards, that should be minus. Okay, then we rearrange equation. We got Sy equal to polynomial of T2. Okay, then we call this one equation 1 for simplicity. Okay, so that's one thing that we know the expression next. So the sx, the horizontal distance of projectile is what? Okay, is the distance here 200 meter plus some value that will reach to the final uh, position. So Sx, the distance in horizontal axis is simple. We don't have acceleration in x-axis, so it should simply the velocity time the flight time. So in this case, I would like to assign the distance from B to the horizontally to the final impact as the letter D. Okay, so the total displacement in x-axis should be 300 plus the distance D. Okay, 300 plus D equal to the velocity here distribute in x-axis, so 70 times cos 35 degree. Okay, time the flight time. Okay, then we call this for simplicity equation number 2. Okay, so now one of the interesting feature that the circular curve has is that once we identify the center, we do a circle, a full circle here. We could see that this curve here is a part of a full circle. Okay, and now that full circle, if we draw the spatial axis, especially for center, we call it y prime and x prime. We can know that uh, in the this green circle, there should be some constraint or some function that describe the a circle graph as shown here, or a circle line as shown here. Okay, so the if we drew a blue line from center to the impact point here, okay, that line should make some angle with x prime. Okay, so the reason why I make the data assign variable here is because surely in any point of the curve, the radius that will reach, sorry, the distance from center that will reach to that certain position should be 150 meter always because it was the radius, right? But what we don't know is that the theta and the angle theta, or how uh, from the x-axis or even from the y-axis, how is the angle act between those two. Okay, so one thing for sure, the distance is 150. Now the unknown is in the theta here. Okay, so we need to determine that theta. Okay, so theta will be represented by the distance d. Okay, so d here, if we it's a parallel line with this line, right? So that means this 150 time cos theta will equal to the distance d. So that's why this expression is valid in this case. We call it equation 3 for simplicity. Then another thing to notice is that in this triangle here, so we already know inclined line, which is 150. We know horizontal, which is d. Okay, so the next thing is the vertical distance from here to from x prime to the impact point. That should be 150 minus distance sy. Okay, so because total from here to here is what, 150, right? So this uh ratio this portion of distance should be 150 minus sy. Okay, so then that is another expression, we call it equation 4. Okay, so equation 1 and 2 is directly from the projectile motion equation. 3 and 4, however, is simply from the geometry of a circular path. Okay, that's how beauty of it. We get two equations from just geometry. Okay, then if we look closely, what they have in common. Okay, so equation 1 has sy and t, equation 2 has d and t, equation 3 only theta and d, equation 4 only theta and sy, because those two doesn't depend on time, it's just the constraint of the circular path. Okay, because the impact point is lying at the curve part, so whatever the constant function of the curve, it should follow. Okay, makes sense, right? Then okay, we move on how to further solve this. So we substitute equation 4 in 1. Okay, this is equation 1, this is equation 4. Reason being is that equation 4 have the sy as common as as same as equation 1. If we substitute that, we left us with the polynomial of t and psi theta. Okay, we call it equation 5, for example. Now we substitute 3 in 2, that is because equation 2 has uh, variable d. Okay, equation 3 had also variable d and theta. Okay, we substitute that in, we get the if we arrange the equation, make it more simple, they will give us they will give us with this equation of theta and variable t. Okay, so as I mentioned in a previous video about this conversion, you have cos one equation that have cos theta, another one with sine theta. The only way, or maybe one of the few way to convert this to solve it further, is that you have to change cos theta to sine, or sine to cos, or change those two to something. Okay, in this case I chose to change cos into sine by powering two sides of this equation. Then the cos will turn into cos square, cos powered by 2. Then from geometry, the rule of trigonometry, we can convert cos square into 1 minus sine square. Okay, so now I convert this equation 6 from cos theta, cos theta square into 1 minus sine theta square in this term. Okay, calculate it, and we left us with again sine theta equal to plus or minus. I already explained why we have plus or minus in previous video. Okay, and then after that I substitute, right, I call out this equation 5 here because it have sine theta inside, and I present it again here, and putting the sine theta this expression inside, we left with this chunk of equation. And once again we are once again we moving this 150 inside by powering by 2. Okay, this term and this term here cancel out. We do some rearrange of mathematics. We got left with polynomial equation in both sides. It seems pretty messy, but if you rearrange it carefully, you will get this fourth degree of polynomial equation here. Okay, pick up your favorite calculator and plug in the coefficient here. You will get the time possible for two values. Okay, 1.7 and 2.7 seconds. Okay, now to verify which time is the correct one, okay, we're moving on to determine the actual time. Okay, so t has two values. We don't know which one is the correct one. Okay, we all we know is that it's valid mathematically, but let's see, is it valid in this question? Okay, so we have to look at the physics of like more like reality of the problem. We say that psi theta equal to plus and or minus because we obtained it from the square root. So that means if we substitute 1t into this equation, it should give us the theta of positive. Okay, so I substitute 1.7 and I chose, and I found out that if I substitute 1.7 inside, the square root is minus, which is uh, we would return to imaginary answer, and the angle will be not valid at this point. So we select the T2, which is 2.7 seconds. Okay, we uh, substitute our T2. Oh, sorry, this is should be 2.7. Okay, we substitute T2 equal to 2.7 uh, inside. Okay, T2 equal to 2.7 around. Okay, we substitute T2 here inside, and we will determine the angle theta. Okay, angle theta equal to, in this time, what inside the square root is not minus anymore, so the value is valid. So psi theta equal to plus or minus 0.29. We turn only plus 0.29 because, again, if psi theta equal to minus, that should give us quadrant 3 or 4, which is not possible in this case because if we go 3 or 4, for example, start from here is uh, so normally the quadrant 1 is from here, right? But since the angle start from here, uh, this will be our quadrant 1. This will be quadrant 2, 3, and 4 accordingly. Okay, so side side data we chose positive because we know that the angle should be on quadrant 1 or 2. Okay, but clearly cannot be 2 because the is only the quarter of the circle. It should be only in this line. Okay, so enough with that. So we moving on to angle theta. We calculated to be 17 degrees. So we, of course, clearly if that I try to substitute the minus sign inside, turns out that angle is minus, which is not possible because it will be here. Okay, there's no circular part in there. And okay, theta equal to 17.27 degree. Okay, now that we know the angle theta, we would know the distance d and the vertical distance sy. Okay, we pick up equation 3 that is indicate the relation between d and theta. Plug in theta equal to 17. We got ourselves the distance d equal to 143 meter. Then that means the total x coordinate should be 300 plus that value, okay, plus 143, left with 443 meter from the origin and then until the impact point in x-axis. Now, what is sy? Okay, we call out equation 4, that is 150 minus sy equal to 150 sine theta. Plug in the theta equal to 17. Get ourselves the sy equal to 105. Okay, like I mentioned, sy will naturally be the y-axis because it starts from horizontal line up into the impact point. Okay, so that is, sorry, that's it, the end of this question. I know it's pretty long one, but it's pretty interesting to uh, try to find relationship between the flat line and the curved line. In this case, if you know how to solve this one, especially in this part of, especially in the equation 3 and 4, they will be very helpful. So that means if the curve here change into maybe some parabolic curve, some weird angle or weird graph, if you could find a function of that, that should be a piece of cake because now you know the relationship, not only the projectile motion but also where it landed. If you combine those two, find the mathematical relation of those two sides, the geometric, projectile motion, any curve in the world, you could solve it. Okay, so that's how important this understanding is. Okay, sorry, I brag too much after question, but that's it. This is the end of the video. I hope you guys learn and then understand more about this concept. And again, thank you for watching this long. And stay tuned for the next question, what it will be and how exciting the question would be. Okay, so enjoy the video, enjoy your time studying, and we'll see you guys on the next one. Bye bye.